Hello everyone, welcome to this video by 𝗏𝗃𝗀. So far we have covered all the major time complexities, be it linear time complexity, constant time complexity, uh, logarithmic and exponential. So this was so far it was the syllabus for the time complexities that you need to know. Right now we have just focused only on the conceptualization of these time complexities. We haven't gone in depth into code to how to do this, right? And that is totally perfect right now, because we are first of all building this because you all are new to DSA, right? You don't know how to visualize the code, you don't know how to have the logical intuition of the code. So we will spend good time initially in theory, like putting everything in theory and mind, right? So that you are totally ready before you start coding and before we start algorithms, because algorithms are very like they're limited. For example, especially if I talk about data field, data engineering, data science, they will not test you on a very complex algorithm. They will give you easy to moderate algorithms only. But main thing is that you should know how to understand the coding structure. Okay, so that is something we will be focusing more in the initial lectures. So right now that you have understood all the time complexities, I want to bring a couple of concepts. So I'll be creating 2 to 3 videos on these. The first concept is dealing with the constants. So what are the constants we will discuss in this particular video? How to determine the uh, how to determine the overall time complexity of a code with multiple constants. So those things we will be speaking about in this particular video. Now let's start with the discussion of this video. So let us say we have a code here. Now we have already discussed this particular part, but let's say we have a code where we have a sum function which takes two elements a, b, okay, and what it does, it returns the sum a plus b. Okay, and it's pretty simple. Now when I run this particular sum function with, let's say, 7,11, it will give me 18. Pretty simple. Now what is the time complexity of this particular code if I talk about? So for example, let's say I have created this function sum ab and return a plus b. So now I have to discuss the time complexity for this particular code. So what is time complexity? Time complexity is the rate of, if you remember, rate of change of operations, rate of delta operations with respect to versus data size. So as your data size increases, is there any increment in the number of operations that are conducted in your code that particular time? Okay, now in this particular code, if you see what all steps are there, what all operations are being performed, there's only one operation, that is return a plus b. Now tell me this thing, what if this particular thing increases? For example, instead of two variables only, I introduce c, d as well. Okay, so what will be the return function? So return function will look like something. So let's say there are 4 variables. So it will look like a plus b plus c plus d. So what do we see, that the number of operations which were happening in the code earlier, it was also 1, even when we had two elements, and now also it's 1 when we have 4 elements. And does not matter how many elements I take in here. It can be 100, it can be 1000, it can be 1 billion, anything. I am executing only one operation. Okay, so what time complexity is this? This is O1. Correct. So let's just figure out this in code. So this particular thing is O1 time, because this is only O1 time complexity, because this operation is only one operation is running in this particular code. So you can introduce as many variables as you want here. It will not impact your runtime of this particular code. So you need to understand, so is this an efficient code? Yes, this is very efficient code, because you are just returning some of whatever input you give to the code. Now let us discuss another scenario. For example, let me remove this particular code. So let's say we have an array equal to let's say the array has 10 elements, 1 2 3 4 5 6 7 8 9 and 10. And let's say I write a code def print n, okay, and let's say it takes your input array and prints all the elements inside the, so what will be the code? Let's say for I in range 5 print arr I, okay. So let's say this is the code. Now what will be the time complexity of this particular code? So now remember that so you might think that this could be on because I'm running a for loop here, and for loop will iterate over each of the element, correct? And so like a lot of you might be thinking right now is that this is on, but the main problem is that on is not the right answer. So let's figure out why this is not the right answer. Is not the right answer. So what happens here is, let me visualize things here first of all. So let's break this code one by one. In what is happening, you're doing for I in range this. So technically what is happening is that for I in range 5. So what does range 5 means? 0 1 2 3 4. It means that I will take values from 0 1 2 3 4, correct? So let's say let's create the list that we are having here. For example, we had a list of 5 elements here, okay. So this was the list that we initially had. So let's say this is pretty, so 1 2 3 4 5 6 7 8 9 and sorry for this is 10, okay. Now what I'm running, my code says that for I in range, so for I in range 5, okay. So what does range 5 means? It will operate from 0 to 4. So what are the index numbers? 0 1 2 3 4 5 6 7 8 9, and I'm printing all the elements which are lying at index 0 1 2 3 4 5 0 1 2 3 4. So what is happening now? Let us say this list has size of 10 right now. Now if I increase it to 20, it does not matter with the size of the list. I am only printing on the first 5 elements here. If you see, I'm only printing first 5 elements. When I write range 5, I'm not saying that iterate over the whole length of the list. I'm just saying that go over first 5 elements and print it. So what will be happening? It will be printing only these numbers 1 2 3 4 5, and it will not print any number beyond that. So technically, if I run this, for example, right now, print n and let's say arr. If I pass this array to it, it will just print 5 elements. Now if I increase 11 12 13 14, it will not, so it will not execute those. It will still remain 5. So the number of operations in this particular code remain to be 5 only. It is not increasing with your increase of data set, correct? And this is the reason this particular question belongs to O1 time complexity, not On time complexity. Lot of you might have this because you are learning things right now, you might think that okay, wherever a for loop come, it means it's an On time complexity, but this is not the scenario. So while determining time complexity, you need to see how many operations are there, and the main question that you need to see is my number of operations increasing with increase in data set, okay. So try to do these particular small simulations in your code and see that if I increase my data set by a little bit, do I see any increment in output, right? If that is happening, that it means it is not constant time space. This is some another time complexity, and then you evaluate which type of change is happening. If the change is happening linear, it is a linear time complexity. If the change is happening like quadratically, it is a quadratic time complexity, and so on, that you can go on discussing. So this is a very good question to understand the concept that for loop does not mean n time complexity by default. For loop, what matters is that how many times is this particular for loop getting evaluated. In this particular question, as I repeat again, it is evaluated at a fixed number of times, and that number of time is not increasing. So this is O1 time complexity. So I hope you understand this particular explanation. So now let's move to another concept that is called the dropping the constants, or talking about the constants in a particular code. So let us try to understand this particular scenario, and please, as I mentioned, just pay a little bit more focus on this particular example. Let us say you have this array of 10 elements. Now you want to write a function to print all the elements one by one. So how will you do that? Pretty simple. You will do def print n. You will take array as input, and you will write down for a in array print a. Correct? Pretty simple. It's a simple code, and you will you'll simply call this function print and n, and you'll pass this array. So once you do this, what will be happening is you see all the elements getting print 1 to 10. So what is the time complexity of this particular code? It is O n, because we see that in this particular case, this loop is executing over array one by one. Now if I increase this like 11, 12, 13, 14, the number of operations will increase. Correct? So, and because number of operations are increasing with respect to the size of the data set. For example, if I increase 5 elements, I see that there are 5 elements. There are 5 elements increase only. Okay. So this technically means that this is a linear time complexity where the growth of your operations vary linearly with your data. Correct? Now let's see another scenario. What if I introduce another code below this? I do this thing. So I go here, I have executed this particular code for b in array print b. Now this was a time complexity of on, a particular code, and this is another part of this which is on as well. Now when I print this particular, I see that I'm getting multiple times. For example, print b. I have to print print n function arr. Okay, print n. So let me just change this name here. So this is print a, and let's call it print a, and the variable name is arr. Okay, and now let me call this. So what do we see here is we are executing from 1 to 15, and then again from 1 to 15. Let's remove like these 5 elements. Let's just focus shift to just 10 elements. So we see that it is printing 1 to 10, 1 to 10. Now the number of operations of this particular code has increased. Now it is 10, 20. Previously it was 20. So what do we see here is that when we had, so what is the time complexity of this particular scenario? We have on plus we have on. We have two codes working parallelly, on, and so the combined time complexity of this particular code will become 2O2n. Correct? But further, the main thing which comes here with the time complexity is that this constant which is present in place of n, this holds no value, and this is called the concept of drop constants in time complexity. So irrespective of for example, let's say there was code where you had multiple, let's say you had on as well, 3 ons, so you could have been doing 3n. This will still resolve, this particular thing will get eliminated, and eventually the overall time complexity of this particular code will remain on. Okay, so if you see, let's say I add another syntax below this. for C in array, print C. Okay, you can see the number of operations of this particular code are higher than previous, but we are talking about the rate of growth of operations as the number of elements reaches a very high level. So in time complexity, it is not about 5 elements, 10 elements. We generally see that how an algorithm behaves as your data set increases to very large. For example, your list, let us say, has an element 1, 2, 3, 4, 5. There are presently only 5 elements. So let's say one of the ON will be having 5 operations. O of 2n will be having 10 operations. Okay, now let us say this size increases from 5 to 100. So how many operations will this have? So 100 into 5, it will have 500, it will have 1000. Now 1000 and 500, they significantly are same only when you compare. Let's say this data size increases to infinity. When this data set increases to infinity, the number of operations, 1 infinity and 2 infinity, there's no concept. You never say that 1 infinity is greater than 2 infinity, right? This type of concept does not exist. So this is what we apply here, that this constant which is applied in place in front of your n has no value. So you have to always drop. So for example, O of 2n, or you can say, will be same as O of 100n, will be same as O of 1000n, will be same as O of n by 2, okay, O of n by 2, or it will be same as O of n. Okay, so when there is a code where you have multiple branches which are of same linear time complexity, they will not increase overall time complexity of your code. And this because we do not see the growth with respect to how many operations are there in the particular code. We see that as my data set size increases to infinity, is the rate of growth, is it linear or not? That is what matters to us. Okay, so for example, we do not care whether it is O. Now, point is that when you create a particular curve, O of n will look like this. Okay, and O of 2n will also look similar to this only. It will not technically grow your operations too much. It will stay O2n here only. So these all will be here only, and relatively they will not increase the overall time complexity. So as I mentioned, O of n, O of 2n, O of 3n, all this remains same. Let's say when you do till O of 100n or any number, it can be 1000, lakh, 2 lakh, whatever things. So this is something you need to put in your mind very straight, that when someone asks you what is the time complexity of this particular code, you will not say it is O of 3n. It will still remain O of n only. If you are having doubt, visualize it from this point of view, that what if this data size increases to infinity? Okay, when this data size increases to infinity, O of 3 infinity is same as O of infinity. Okay, so that's why we call it O of n only. And that is the main concept behind this particular. So now based on this particular task concept that I explained, you have an assignment after this video. So if you go to this particular, so you'll find this particular Python workbook attached to this to the YouTube description of this video. And you see there are 5 codes I have written. So code 1, and the question says what is the time complexity of this particular code. Now you have to analyze by checking the whole code, that how many operations are happening, how operations are increasing with respect to your as your data size increases, how your operation is increasing. Is it constant? Is it growing linearly, or it is going quadratically? Okay, in linearly, it does not matter if it is O of n, if it is O of n or O of 2n. Everything will be called linear only. Okay, so either if it is O n square, that is different from O n or O 2n. Okay, so you have to see whether a time complexity is O n, it is O n square, O n cubed, or it is O1, or it is n log n, or it is log n, like whatever we discussed, or it is 2 raised to the power n, or it is 3 raised to the power n. Now, depending upon whatever scenarios you see, so there are 5 questions. This is an assignment which you need to do, and you will have deadline by this Sunday. So this is code 2, code 3, code 4, code 5. So just try to analyze whatever time complexity we have discussed so far. See that as my data size increases, how my operations are increasing. Is my operation going linearly? Is it remaining constant, or it is going quadratically? If you can visualize that particular part, you are good, and then try to answer with your logic. So don't only comment answer. I don't want anyone to just write this is ON. I want your reasoning as well. And please don't refer to ChatGPT, don't refer to Google, don't refer to anything right now. Because if you really want to build concepts in your mind, don't refer to those things right now. In future, when we'll be doing codes, I will myself say that use ChatGPT for this particular task. But for this particular scenario, try to understand the code yourself only and try to answer. I will cover the solution of these particular 5 questions in the next video. But before that, I want you all to finish this assignment. You will have time till Sunday. So today is Thursday. You will have time till Sunday to finish this assignment. Okay. So I hope this video explanation is clear to you. We will be moving forward with other type of so just like we discuss dropping constants, there are some other properties as well that we will be discussing. So we'll cover that in next video. So far I hope you are learning. If you're facing any issue, please comment below the video, or you can reach out to me directly as well. You know how to reach out to me. And so thanks for watching this video, and I will see you in the next video.